good evening, or maybe it's morning, grade 10s. This is a quick video, well, quick, it's about 10 minutes, of question 6 of the exam paper in 2017. And it goes through quite step by step. So we move from the diagram, which is blank, down to filling in the diagram with information as we get it. As with any of these videos, make sure you pause as you're going along the video. So don't just sit there passively and go, oh, okay, it makes sense. Pause, okay, try the next question. Now that we've finished A, continue and see if you can do B after that. So yeah, enjoy. Hopefully it's somewhat helpful to some of you. So yeah, enjoy. Okay, question 6 in the 2017 exam paper in paper 1. We've given a couple of functions on a Cartesian plane here, and before we go into the questions, and it'll be up to you how much you write this down, highlight, or just at least look at the diagram and see what are we given. Well, we're given this function f of x equals minus x squared plus 25. What type of function is that? Yeah, it's a parabola. So even if they didn't tell us that this one's f, we'd know that of the thing shown on the diagram, that's f, our parabola. Then we're given a second function, g of x. Again, without being shown which one, what type of function is that? Yeah, it's a straight line. And here's g given to us, so there's our very straight line. From the equations that we're given, we know that plus 25 represents the y-intercept of our parabola, and that plus 20 over here represents the y-intercept of our straight line. Doesn't look like we're going to need that point in the question, seeing as we haven't even been given a letter for it. Now let's look at some of the interesting points on our graph. Yes, interesting. And that is, point A is an x-intercept of the straight line, the parabola, and where the two functions equal each other. Point D is where the functions also equal each other, so there are 2 points where the functions are equal to each other. And we've got point B, which is the x-intercept, or the other x-intercept of our parabola. And we're given these points H, M, and E, which lie on a vertical line, which means their x coordinate is going to be the same for each case. So if we know what the x value of E is, we know the x value of M and the x value of H. Okay, so we just had a quick look at our diagram. As I said, you'll decide how much you go through this, how much you color it in as you're going. I'm going to leave this colored in so we can refer to it later, and you kind of got a sense of what we've got so far. Now we can start looking at the questions. Our first question is to write down the coordinates of E, which is sitting down here, if OE, which is this distance here, is 3 units. In other words, we're given that this is 3, therefore we've gone left by 3, therefore this must be minus 3 on the x-axis. So E is just the point minus 3, 0. And that's going to be quite useful, so let's put it in our diagram so we can have it there for reference for later. Next up in question B, we asked what's the length of HM. So we've got H up here and M down here. What's the distance? And real trick here is, well, the key to the question is, how are we going to work this out? What does that length represent? Well, I'll give you a chance then, hopefully you're pausing the video if you need to hear of, well, if we've got these y values, it's the difference in y values. So let's say, for argument's sake, that this is 16 at H, the y value, and the y value of M is 8. Then we're going to go 16 minus 8, and we're going to know that that distance there is 8. So let's work out how we're going to work out the y value of point H. Let's start with that one. Well, we're given some quite useful information here already from what we worked out in A, and it does have the word hence here, and hence normally means that you're going to be using whatever you've just figured out. We've just worked out that E is at minus 3, 0, and where that's going to be useful is that our point H, we've got its x value. If you remember right at the beginning when we were looking at the diagram, we said, well, H, M, and E all have the same x value, so this is sitting at minus 3 something. We don't know what the y value is, and the same applies to point M. The x value is minus 3 because these x values of H, M, and E are all the same. Let's start with point H, and H lies on F. So the equation that we're interested in is f of x equals minus x squared plus 25. So if we input minus 3 to our equation, then our output, our y value, is also going to be on that line. So if we work that out, we get that f of minus 3 is 16. In other words, we've just worked out that the y value at that point is 16. And we can do something similar for point M. Point M lies on the graph g of x equals 4x plus 20. So we can input and say g of minus 3 will give us the y value that we want. So 4 times minus 3 plus 20, which gives us 8. Therefore, this y value is 8. Therefore, hm is simply the difference between those two, 16 minus 8, which gives us 8. In other words, this distance over here is 8. Now we move on to question C, and we asked to determine the value of a if g of a equals 12. So we're working on this straight line g, and we're saying, well, g of a equals 12. In other words, the y value equals 12. Well, we know this value over here is 20, and we just worked out that this value is 8. So it's sitting somewhere in between. Let's take a guess and say that it's sitting over here, and we've got this value here. We know that its y value is 12, but we don't know what its x value is. So we're dealing with g of x. So g of x equals 4x plus 20. So similarly, g of a is 4a plus 20. Now we know that g of a is 12, and we know that g of a is represented by 4a plus 20. We got an equation that we're going to solve, and we get a equals minus 2. In other words, we could rewrite this over here and write it as minus 2, 12. My guess wasn't too bad. It would be a little bit further left if this diagram were to scale. Next up, we asked to find the coordinates of D sitting up here. Now, D represents one of the points where the functions are equal to each other. A also represents another point where the functions are equal to each other. So when we solve this, we might come up with the coordinates of A and D at the same time, but we'll focus on D. Now, let's look at the x values of D. What's going to give it away? Let's see, we've got D sitting over here. What's its x value? Positive. What's the x value of A? Negative. What's the y value of D? Positive. What's the y value of A? Well, it's going to be 0. So we can differentiate which point we're getting. So what did we say? The two functions are equal to each other. F of x equals g of x. Simple as that. So now we can just solve. And we've got and if we look here, we've got x equals minus 5. That's clearly going to represent that point A. And x equals 1 is going to represent point D. And we're asked for the coordinates of point D. So we're going to use the second point, x equals 1, to work out what the y value is so you can find out D. Well, x equals 1 we can substitute into either f of x or g of x. I'm certainly going to choose g of x because it's a much easier equation. So g of 1 is 4, 1 plus 20, which gives us 24. In other words, the coordinates of D are 1 and 24. So we can put that in our diagram. So it's quite nice, we're just keeping track of things as we go along. So our diagram's got most of our information. Might not have everything, but it's still got most of it as we're going along. In E, we asked for the range of f of x, and basically we need to ask ourselves, what does range represents? Range represents the y values. So what's the biggest and the smallest y values that we're looking at here? Well, going from the top, the biggest value is at C, and that's the highest value. And remember, right at the beginning we said C here is represented by 25, the y-intercept. So we know that y is definitely going to be less than or equal to 25, because that's as high as it gets. And what's the lowest that it can possibly get? Well, we can keep going down and down and down and down and keep going till negative infinity. In other words, y is less than or equal to 25, but there's no bottom value, so that's all you have to do. And let's add that point in, seeing as we've got it. So this point here is x is 0, y is 25. We're not going to need it, but might as well keep adding it in. On to the last bit here, which is for which values of x is f of x greater than g of x? Now, what does this mean, f of x greater than g of x? F of x relates to y values. And g of x to y values as well. So we're asking, when is f of x greater than g of x? In other words, when is f of x above g of x, is what the question's asking. So let's highlight our graph and see what's happening. So when is the blue graph above the red graph? Well, I'm going to highlight it in purple as we go. So as we're coming along from the left here, we reach point A. Before that, the red graph is above the blue graph. Then we reach A. And for all of this part here, the blue graph is above the red graph, blue graph still above the red graph, blue graph still above the red graph. Ooh, at this point here, at point D, then the red graph goes above the blue graph. So in other words, we're just looking at this part here. So between A and D is where the blue graph is above the red graph. So let's just write that down and say, well, we're thinking it's between A and D. So we just need to know the x values of A and D. We know the x value of D because we can see it, and we filled in our diagram as we went along, so it's quite easy. We can see it's definitely there. 1 is going to be the biggest value, and it's strictly above, so we're going to say that. And what is the x value of point A? And x value of point A we worked out in question D, and there it is, sitting at -5. So in other words, between x minus 5 and 1, then f of x is above g of x, f of x is greater than g of x.